Hey folks, this calculus lesson is we're going back to derivatives here. We're going to derive the natural log function. So let's go ahead and do a little bit of review of logs, you guys. Remember this, you guys? The log of 1, the natural log actually, the natural log of 1 equals 0. All right, because remember it's base e, so e to this power right here equals 1. Remember that rule right there? This base to this power over here equals that. So the natural log, the log of anything of 1 always equals 0. All right, and the natural log of a times b is you separate them up with a plus sign. Natural log of a plus the natural log of b. And then when you divide, then you separate them up with a minus sign individually. And this little power right here comes out in front and it gets multiplied. So it's n times natural log. That says n times natural log of a. Okay? What else do we have? All right, so let's expand this, you guys. All right, so this one's going to be the subtraction one. There it is. That's the answer. All right, this one, let's go ahead and recognize that it goes, the square root is to the 1/2 power, and then this 1/2 power comes out in front right there, so it's 1/2 natural log of 5x minus 1. Remember this from your Algebra 2 class, you guys? All right, so this one's a little bit more involved, so let's see what I do here. I separated them up with the minus sign first, and then I'm going to slide the powers out in front, and so let's see. So this is the cube root right here, so the cube root is to the 1/3 power right there. So there, I'm going to slide this 1/3 out, and then I'm going to distribute this negative through. Okay, and I separated up natural log of x with this multiply with the plus sign right there. All right, you guys remember that from Algebra 2. That's why I'm going kind of fast. It's a review, and that's the final answer right down there. Okay, all right, so evaluate each logarithm. Okay, these are just plugging them in the calculator, so there you go. That's easy stuff. And then the derivative of natural log, you guys. The derivative of natural log is its chain over the reciprocal. Okay, so the chain of x is 1, so it's 1 over x right there. Okay, and x has to be greater than 0. Okay, if I had anything else, it's always the chain divided by the reciprocal right there. Okay, so the derivative of any natural log is the chain divided by the reciprocal. All right. So, and the natural log of absolute value is the same, the chain divided by the reciprocal. Okay, the only difference is we don't have to restrict it to be greater than 0 because this absolute value does that for you. All right, so don't let the absolute value scare you. It's real easy. Okay, so let's try this, you guys. Okay, so the chain is 5, so the chain of 5x, the derivative of 5x is 5, and then over 5x. So 5 over 5x is 1 over x. Okay, easy, huh? All right, so the chain over the reciprocal, so 3x squared over x cubed plus 11. Okay, okay, this one I got to do product rule. Remember, it goes f prime g plus fg prime. Okay, so here it is right here, and I finally get natural log of x plus 1. Okay, nice and easy. All right, let's try a challenge. Oh, not this one here. All right, so this one here, I'm going to do this 3 comes sliding down, and then it becomes decreased, and then times the chain inside. The chain of natural log of x is 1 over x. All right. Okay, so and then this 1 over x I brought out here with this 3, so it's 3 over x. I think that's the answer, yeah. All right, let's try this one here, okay? So I'm going to go ahead and separate them up using my log rules right there, and then take the derivative of each one of those little pieces, okay? And there we go. That's the answer, okay? Nice and easy. All right, well, what if you had, oh, I'm sorry, I didn't clean it up. So now, sorry, so now that was just y. I just separated up with just y. And then I take the derivative of that. So the derivative of this is 1 over x. The derivative of this is the chain divided by the reciprocal. So don't forget the 2. There's my 1/2 right there. And then the chain is, heck, I think the chain is 4x right here, you guys. So yeah, this is 4x. I wrote 6x right there, but it's 4x. Oh, I know what I did. Okay, that's supposed to be a cube. That's supposed to be a cube, and that's supposed to be a cube. All right, so I'm going to save some time. I'm not going to put in the cubes right here. It'd just take too long, I think. Let's see. What if I did that? Yeah, I knew that was going to do that. All right, so they're just cubes right there. Okay, so that's where I got the reciprocal. Same with that. That's a cube also. It's going to be I'm going to waste too much time with this. So. Sorry about this, you guys. And then finally, so there's my my 6x squared right there, the chain of this right there. Okay, and then we're going to clean it up right there, and then there's the final answer right there. Okay, it went back to 2's because I did it on the next slide, so I'll fix that when I teach this in my class right there. Okay, alrighty, so let's see, that's on page 35. Alright, talking to myself. Okay, this one here, you guys, there was no natural log on this one right here. So what you could do is you can do quotient rule with this, you guys, or you can do another trick is to natural log both sides. And then watch, when I natural log both sides, I get that right there, and then I can separate this up using my logarithm properties right there. So the natural log of y equals, for this 2 comes down, and then this this to the 1/2 power comes out in front right there. And then I can derive this. So the chain of this is dy over y when I take the derivative. So now I'm going to take the derivative. Okay, you guys with me? And let's see. So I'm going to clean this up a little bit right here. So I get to that right there. Okay, and then I multiply both sides by y. Okay, so I got rid of this y right there. I multiply both sides by y. So this dy is y prime right there. Okay, and then this 1/2 and this 2x canceled out right there. All right, now what I'm going to do is clean this up. I'm going to get a common denominator right here. So I'm going to multiply this fraction by x squared plus 1 over x squared plus 1, and this one by x minus 2 over x minus 2. I'm going to slide that right over there. And then this y right here, I'm going to go ahead and substitute this. This is y right here. I'm going to put this y in for that y right there. All right, so that's what I get right there. Okay, and there I am combining and all that stuff. So I get to that stage, and so I'm going to show this part on the next slide right here. All right, and then what I'm going to do is I'm going to go ahead and cancel out this x minus 2 with one of those x minus 2's, and then this is x squared plus 1 to the 1/2 power times x squared plus 1 to the 1. So I add those exponents. 1/2 plus 1 is 3/2 right there. Okay, so there's the final answer on that. All right, and then that's probably the hardest one of this stuff. Okay, so number 7, find the derivative of this guy, and so it's just going to be the chain. So the chain of cosine is opposite sine, and over the reciprocal. So I get that comes out to negative tangent of x. All right, and then find the relative extrema of this guy. Okay, relative extrema means derivative, you guys. So I'm going to derive that, chain divided by that, and then I'm going to set that equal to 0. Okay, and I get x equals -1, so I test with the y prime. I tested it in right here, or actually right here, to see if it gives me negative when I plugged in 0, and it gets me positive when I plugged in 2. So there's a relative min at -1, and then plug in -1 right here, and then you get 2 on that. Okay. All right, so that's it, you guys. If you're in my class, I would assign that for your homework assignment. Take care, you guys.